look at trig functions of any angle. So just as a review, what are the definitions for sine theta and cosine theta? Define a quadrantal angle, and then what happens at any multiple of 90 degrees or pi over 2. So pause it, see if you can fill this out on your own. So remember that sine of theta is just our y value. Cosine of theta is just our x values. And that's specifically for the unit circle. So to define a quadrantal angle, it's an angle that terminates on an axis. Terminates on an axis. And then at any multiple of 90 degrees or pi over 2, two of the functions will be undefined. So reference angle relationships. So let theta be an angle in standard position. The reference angle for theta is the acute angle theta, and this little apostrophe there is just prime, so theta prime. It's formed by the terminal side, terminal side of theta and the x-axis. Okay, so it's the terminal side of theta and the x-axis, specifically the x-axis, not the y-axis. The relationship between theta and theta prime is shown below for non-quadrantal angles. So before we worked on quadrantal angles where it stops on an axis. So now these are non-quadrantal angles theta. And it's such that theta is between 90 degrees and 360 degrees, or in radians, that's pi over 2. Theta is between pi over 2 and 2 pi. So here's quadrant 2. I'm going to show you the formulas for these, but really after a while, you're just going to be able to look at it and just say, oh yeah, I'm just trying to figure out how far I am from the x-axis, and you don't have to worry about these formulas. For those of you that really like formulas and memorizing it, then maybe that's what you might do. So looking at quadrant 2, the terminal side ends at quadrant 2. We want to figure out what is this reference angle. And again, it's in reference to the x-axis. So the degrees, what would you do? So for theta prime, you would have 180 degrees minus theta. For radians, that would be theta prime would be pi minus theta. If you were in quadrant 3 here, okay, you would take theta to find the reference angle. You would take theta and subtract 180 from it. In radians, you would do theta minus pi. If you were in quadrant 4, again, going to the x-axis here, the degrees, you would take, if theta prime would be 360 degrees minus theta. In radians, that would be 2 pi minus theta. So let's take a look at some examples to find their reference angles. So this is to help prepare us for finding reference angles and then actually finding exact values. So we have 5 pi over 3. Now, I personally do not see 5 pi over 3 and know where that is. So what we're going to do is we're going to go ahead and convert it to degrees. And then once we find out what the reference angle is, and then convert it back to radians. So that way it's less to memorize. We have 5 pi over 3. In order to convert that, we have 180 degrees over pi. So 3 goes in 180 60 times. So this is going to be 300 degrees. So I know where 300 degrees is. That's in quadrant 4. So if this is 300 degrees, we want to figure out how far is it to 360 degrees. So instead of thinking about the formula, you just think about how far is it to that. So in order to get there, that's really just 360 minus 300, or you know that that's just 60 degrees. Now we have to convert it back to radians. If it starts in radians, you convert it back to radians. So 60 times pi over 180 degrees. 60 goes into 180 3 times. So the final answer is pi over 3. Now the next one, we have negative 130 degrees. As a side note, reference angles are always positive. Reference angles are positive. So we have negative 130 degrees. It starts here, right, standard position. It goes this way to negative 130 degrees. Now again, we're looking at how far is it from the x-axis. It's the closest x-axis here. So if we're going to there, this is actually negative 180 degrees. We know that this quadrant is quadrant 3. So we want to go 130 to 180. That distance is a positive 50 degrees. We just want to know the difference. Okay, so that's 50 degrees. That is the reference angle we're looking at. So go ahead and do the next 4, 5, 6, 7, and 8. For 7 and 8, what you're going to want to do is, again, convert these to degrees. So degrees. Figure out what the reference angle is, and then convert back to radians. So pause it right now, try these out, and then when you come back, I'll have the answers. Okay, so we tried these out. The first one would be 30 degrees. The second one, number 6, would be 80 degrees. Number 7, you would have gotten 40 degrees, which converts to 2 pi over 9. And then number 8 would be pi over 4.